This is R.D. Sharma Solution, Class 12, Chapter 17. We are taking the multiple choice questions of increasing and decreasing functions. In the interval 1, 2, function fx equals to twice of x minus 1 plus 3x minus 2. This x minus 1 and x minus 2 are in modulus. So we are talking about the interval which is 1 and 2. First of all, mod x is x when x is greater than 0. It is negative x when x is less than 0. This is a very important thing that has to be very clear to every one of you. Now when you have mod x minus 1, now just put any value between 1 and 2. For example, I take 1, I take 1.5, I take 2. Now just subtract 1, what do you get? You'll get 1, you'll get 0.5, you'll get 1. So you'll never get a negative value. So in between 1 and 2, mod x minus 1 will always be positive. So it will be positive. I hope you got the idea. Coming to mod x minus 2. Now just put any value between 1 and 2. Again, same values I'm going to take. 1 minus 2, 1.5 minus 2 and 2 minus 2. What do you get? You get a negative 1, you get minus 0.5 and a 0. So every time you get a negative 1. That means mod x minus 2, in particular this 1 to 2 interval, will always be negative. I hope you got this idea, because when it will be positive and negative in this interval. So I'm now replacing this x minus 1 by x minus 1. Or you can say modulus x minus 1 by x minus 1. And modulus x minus 2 by negative x minus 2. So I've made it as negative. So when you open this, you'll get 2x minus 2 minus 3x plus 6. So we have 6 minus 2 is 4 and 2x minus 3x is minus x. So this is fx. Now let us take the differentiation f dash x. It is going to be negative 1. F dash x is negative 1. Now this negative 1 is less than 0. Whatever you do, it is a constant. It will always be less than 0. That means this function, whatever you do, it will always be decreasing. When f dash x is less than 0, it will always be decreasing. Negative 1 is negative. It is decreasing. So this is the solution reference for you if you want to do it by yourself. If the function fx equals to cos modulus x minus 2x plus b increases along the entire number scale, then number scale, we are talking about number line. So this function is increasing. It increases. What does it mean? First of all, we have to find a relationship between a and b, or a relationship of a with certain numbers. These are the 4 options being provided. The first point of concern is the modulus x. And again, same thing I'm going to reiterate. Modulus x is x when x is greater than 0. It is negative x when x is less than 0. Alright. So minus x, why it is? Because if something is negative to make it positive, you always put a negative. That is why minus x. Because mod x, always the input can be any number, but the output will always be a positive number. Okay. Negative, put positive, you'll get a positive. Put negative, you'll get a positive. Every time you get a positive. So now we have cos modulus x. What is mod x? It can be x, it can be negative x. So it can be, the mod x is x when x is greater than or equal to 0. You already know about this. And it can, the cos x can be replaced by negative x when x is less than or equal to 0. Not equal to, sorry. X less than 0. X greater than 0 for positive. X less than 0 for negative. Now you know what is cos minus theta. Cos minus theta is plus cos theta. Sin minus theta is minus sin theta. But cos negative theta is cos theta. So both the ways, if x is greater than 0 or less than 0, you'll always get mod x as positive. Alright. So we don't worry about modulus x. You can just replace modulus x with positive x. So we have cos x minus 2ax plus b. And now we'll differentiate it. F dash x is going to be cos x is minus sin x. This minus 2ax will give you minus 2a. This is going to be 0. So this minus sin x minus 2a. Now this is increasing. That means f dash x is greater than 0. So what is greater than or equal to 0? We have minus sin x minus 2a is greater than 0. Minus, I'm taking minus outside. See, I'm not telling you to deal with it, but I don't deal with negatives. Because always the solution goes in other way. So I'll always deal with positive. So I'm multiplying both sides by negative, and I know when I multiply with negative on both the sides, the inequality is going to change. So this is sin x plus 2a is less than 0. So sin x is less than 2a, negative 2a basically. 2a. Again, I get a negative here. Please remember, this is less than or equal to 0. Okay, just because to meet the options, I'm making it as less than equal to minus 2. So finally, you can just replace it. You can multiply a negative, or you can say multiply both sides by negative. This is, I'm not saying you to do it. I'm just doing it for myself because I don't deal with negatives. And multiplying both sides by negative will always change the inequality sign that has to be fed into your mind. Alright. Now tell me, what is the highest and lowest value of sin x and cos x? It's plus 1 and negative 1. So 2a is less than equal to negative sin x, and we need a relationship between a and certain value. But sin x minus 1 or plus 1. But if you say I am lower than the lowest value of yours, or I am higher than the highest value of yours, that is, if I am higher, I am higher than 1. If I am lower, I am lower than minus 1. That is the whole limit of sin x. So minus 2a is greater than equal to 1, because the highest value of sin x is 1. So when you make a relationship here, again you can multiply by negative, which I generally do. But my idea is, again minus multiply, you will get a less than equal to negative half. Okay, I'm not saying you to multiply negative. I'm just doing it for myself. I'm just doing it to get rid of negative and just changing the inequality. So finally what you'll get is a should be less than equal to negative half. All this is not what you have to do. This I did for myself. Again, I'm reiterating. But finally, when you'll solve it, you'll get that a should be less than equal to negative half. A is less than equal to negative half. So this is going to be your answer. The third option is the correct answer. Okay, this is the solution reference for you. And all these things you know already. Only if you go along with the concepts which if you are following me, you know all these concepts now. So this is how we need to follow. Greater than equal to 0, a less than equal to minus half. The function fx equals to x by 1 plus modulus x is, okay, strictly increasing, strictly decreasing, neither increasing nor decreasing, none of these. So they haven't provided us the domain. So we have to find out the domain by ourselves. What is the interval? No, we don't know what x can be placed. So we have to take the cases now. Why? Because modulus x, again, two things will come, negative and positive. So x can be greater than equal to 0 or x should be less than 0. These are the two cases for modulus x. And you already know, I've been writing it many times. Mod x is x for x greater than 0, negative x for x less than 0. This already you know. So this x is greater than equal to 0. Mod x will be x. X less than 0, mod x is going to be negative x. This you already know. Now replace this x by 1 plus x here. This is your fx. And here you'll get fx equals to x by 1 minus x. Because now in the case 2, x is less than 0. And by the definition of modulus, you have to take a negative. Now let us differentiate. And you already know the differentiation of x by 1 plus x. We have already completed this in our previous discussion. So I'm writing the value directly. 1 by 1 plus x square. F dash x of x by 1 minus x is 1 by 1 minus x whole square. Now any value, I told you already, if you take any value and square it, it will always be positive. There can be no reason. Or you can say not square, but anything with the even power will always be positive. So this is, you have square in the denominator. So always positive. Greater than 0 here. Here also greater than 0. So in both the cases, what we got is, it is strictly increasing because the f dash x, which is the differentiation of this function in both the cases, is greater than 0. Greater than equal to 0 is just increasing. Greater than 0 is strictly increasing. So first option should be taken. Now this is the solution reference for you. You can follow this if you want to do it by yourself, and all the content which I have told you, the explanation, you have to write it, right? All right. Don't use the solution directly. Please, I encourage you to do it by yourself. If you are stuck, then you can come here. The function fx equals to this one, lambda sin x plus 2 cos x by sin x plus cos x, is increasing if. So this fx, we will differentiate and we will keep it or put it greater than 0. And we will get the value of lambda with certain relationship with other number. So we have done so much of differentiation up till now that I leave it to you for the differentiation. That is, it will save your time and my time also, because f dash x differentiation you already know. So let me write the differentiation. See, whatever I am writing right now is the differentiation of lambda sin x plus 2 cos x by sin x plus cos x. So you have minus 2 plus lambda divided by sin x plus cos x whole square. This is differentiation. Now we have to equate it, or to tell that it is greater than 0 for increasing. That is what is the relationship we get when it is increasing. Anything with a power even will always be positive. So the denominator sin x plus cos x whole square is positive. So what do you get? Lambda minus 2 in the numerator. It is greater than 0 because if numerator denominator is greater than 0 and denominator is greater than 0, numerator has to be greater than 0. So lambda is greater than 2. This is the option which you have to choose. So I saved the time by not differentiating it. And differentiation, but I'll show you, okay? Because if I do the differentiation, it will not help you. You have to differentiate by yourself. So this is the whole differentiation which I am showing right now. And this is the concept which I used in order to show that lambda should be greater than 2 for this function to be increasing. Now this question is quite straightforward. Whether it be exponential or whether it be log, they follow the same procedure and rule. A raised x is increasing on R. That is, a should be greater than 1. A raised x will be decreasing when a is between 0 and 1. This you already know, and this goes along with log also. But we'll follow the steps. F dash x I am finding out. A raised x differentiation is a raised x log a, base is e. This is greater than 0. Log a is a should be always be positive if you are talking about log. You cannot have a as less than 0. So a should be greater than 0. A raised x will always, whatever value you put, a is a constant here. So whatever value you put, a cannot be less than 0. So anything greater than 0 to the power x, any value will always be positive. And the second term is log a should be greater than 0. I'm not writing greater here. I'm equating it now. That means e raised power 0 is equal to a. E raised power 0, anything to the power 0 is 1. So a is greater than 1. Now let us replace it by the greater than sign. A is greater than 1. So you get a greater than 1. So these are the different options which you can do here. So concept I told you, all proving and all writing is what I have spoken. A raised x should be greater than 0. Log a should be greater than 0. And from there, we devise and finally claim that this is only possible when a is greater than 1. Again, this is a simple thing which you have learned. Log ax, a is base, x is the value for which log has to be taken, but the base is a. Now in both the case, a should be greater than 1 for increasing and a should be between 0 and 1 for decreasing. You already know that. So let us continue our work. Fx is log base ax. We'll differentiate it. When we differentiate it, what do we get? 1 by x log a. See, simply you can write log ax as, when you take base e, it is log x by log a. Base is e. This is how we can do. You know the properties of log. Log base e a is a constant. So there is no point in differentiating it. You just have to differentiate log x, and log x differentiation is 1 by x. That is how the differentiation 1 by x log a has come up. Okay, so 1 by log x log a has come up. Okay, 1 by x log a greater than 0 because it is increasing. It is given on R. R is what? Is the real number. So what do we get? See, if it is greater than 0, x has to be greater than 0 and log a should be greater than 0. Base is e. E is what? E is 2.7. And something number. You already know that. So 1 by log x is log xa. We already know that this a should be between what? X can be any real number. X can be a real number. It can be positive. It can be negative, whatever. But we are not dealing with x. They are not asking. The 4 options being provided is not about x. We can straight away say x should be greater than 0. But the 4 option is related to a. So we have to talk about log a should be greater than 0. Log base e a should be greater than 0. And this log a is only defined when a is greater than 0. And see, a is greater than 1 when it is increasing. And a between 0 and 1 it is decreasing. What is the option? A greater than 1. Okay. So a should be greater than 1 is the option for increasing on R. We would have talked about x. Definitely we should talk about x, but the options, 4 options being given is not related to x. So we have to talk about log a. So this is the whole explanation and writing which you have to do. I hope you'll be able to do it. Let 5x equals to fx plus f2a minus x and f double dash x is greater than 0 for all x which is belonging to 0 to a. Then phi x. X is between 0 and a. You have to talk about 5x and you have to tell about the interval where it is increasing or decreasing. The options are 0, a, minus a, 0, a, 2a. So 5x is given as fx plus f2a minus x. The best thing is to differentiate it. Let us differentiate it. So f dash x you can write here. You can write it as f dash 2a minus x, and then the differentiation of 2a minus x which is minus 1. Okay, so just I'm replacing it. I don't write, I don't write many steps. I do it here only. So I just placed it as negative. This has to be written separately, but I have just written it just to save our time. So now f double dash x is greater than 0. What does it mean? F dash x is increasing function. F double dash x, because this is not a question of this chapter, because double differentiation we have not dealt with in this particular chapter. But let me tell you the concept. If the double differentiation is greater than or equal to 0 and f dash x that simply means f dash x or differentiation of f is increasing. All right, so we will introduce a new thing here in order to prove this all, because there are various things being given here and the concept is very clear. F double dash x greater than 0, that is f dash x is greater than 0, which is increasing. So we are talking about 0 and a. So here what do we get? X is, because the interval is given as 0 to a, so x is less than or equal to a, which is given here. Let us multiply both sides by 2. You get 2x is less than or equal to 2a. 2x can be written as x plus x. X plus x is less than or equal to 2a. Let us take x on the right hand side. So x is less than or equal to 2a minus x. Now let us take both sides by f dash x. I am taking, it will not make any difference. I am taking f dash x on both the sides. So what do we got? F dash x is less than or equal to f dash 2a minus x. But if you remember, we have already differentiated it. Phi dash x is equal to f dash x minus f dash 2a minus x. But this is 1, this is 2. From 2 what do we get? The first value is lower than the second value. I hope you got the idea. From second, the equation which is the second one, it proves that the first term is less than or equal to the second term. If you take the number, let me show you by, that is 1 is less than 2. So when you subtract this 1 and 2, you'll get a negative. Okay, because the first one is lower than the second one, so you'll get a negative 1. So f dash x will be always equal to less than or equal to 0. That is, you are getting a negative 1. So it is less than or equal to 0. This phi dash x is less than or equal to 0. Alright. So this phi dash x is less than or equal to 0. That means we are talking about the decrement. If any differentiation of any function is less than or equal to 0, that means that function is decreasing. But this is decreasing where? In which interval? This phi dash x is less than or equal to 0. That is, it is decreasing in 0 to a interval, which is already given in the question. Alright. So in this interval 0 to a, it is decreasing. That what we can prove here, because most of the things are not given and f double dash x is not pertaining to this chapter. So whatever we could do, we have presented here, and that is the concept. So this is how you are going to go about it. You have to write everything, which is very important. The concept remains the same. If the function fx equals to x square minus kx plus 5 is increasing on 2, 4. So k belongs to this k we have to find out. This belong to where? This is the thing which we have to answer. But the only thing what we can do here with our concepts is we'll differentiate it. F dash x is differentiation. X square is 2x minus k. So f dash x is 2x minus k, and 2x minus k increasing, so it has to be greater than 0. So 2x minus k can be greater than 0, so 2x should be greater than k. So k should be greater than less than 2x. Now this is 2 and 4. It varies from 2 to 4. So you can give x, the lowest value is 2. You can give x the highest value as 4. So k is less than 2 into 2, which is 4. You can replace x by 2 and x by 4. So x is less than 2 into 2 and this k is less than 2 into 4. So k is less than 4 and k is less than 8. So this, if any number is less than 8 or less than 4, that means it is less than 4 only. If my height is lower than yours and your height is lower than your brother's, then my height is lower than your brother's. So k is between minus infinity and 4. So this is the solution. Very straightforward here. If your concepts are clear, you will understand this. Fx equals to minus x by 2 plus sin x defined in minus pi by 3 and pi by 3. Minus pi by 3 and pi by 3. Pi by 3 is 60 degree, and we are talking about negative 60 degree. That will be the mirror image of 60 degree if you make that thing or try to show that thing in the Cartesian coordinate system. F dash x is what? Let us differentiate this first. F dash x is minus 1 by 2 and sin x will be cos x. This is your f dash x. Now you have to tell whether it is increasing, decreasing, constant, or none of these. And the interval is also provided to you, which is negative pi by 3 and pi by 3. So let us come to because we don't have anything. We don't know whether it is less than 0 or greater than 0. So we just have to deal with the interval. See, cos pi by 3 is 60 degree and cos minus pi by 3 because cos minus theta is plus cos theta. So even if you put cos minus pi by 3, you are going to get half only. Cos negative theta is cos theta, and if you take sin minus theta is going to be negative sin theta. But the first quadrant and the 60 degree, let me draw it. 60 degree is this one. What will be minus 60 degree? It is the lower one. And in the first quadrant, all are positive. Add sugar to coffee. Second and third quadrant, cos is negative. Fourth quadrant, it is going to be positive again. Alright. So cos x will always be greater than or equal to half from here, from the diagram. So cos x will always be greater than or equal to half if you deal with minus pi by 3 to pi by 3 interval. What do you have f dash x? Cos x minus half, which we already differentiated. Now it is saying that cos x is greater than or equal to half. It is always, this cos x will always be greater than half. Again the same concept. If you take the minimum value of cos x, it is negative 1. What is the highest value of cos x? It is positive 1. So you put negative value, you put positive value and see what do we get. Okay, cos x is all greater than half. And once we have cos x which is greater than or equal to half, and you subtract half from it, you will always get a positive number. I am saying x minus y. X is always greater than half. Say x is always greater than y. So you will always get value which is greater than positive, which will be positive, or the least possibility is 0. So it will always be positive. So f dash x will always be greater than or equal to 0, which means this function is increasing in this negative pi by 3 and pi by 3 interval. So this diagram is very important. The concept of trigonometry is very important. So this is the simple explanation and reference for you. If the function f(x) equals to this one is increasing on R. Now increasing. First let us differentiate it. The best thing is the differentiation in increasing and decreasing function. We'll differentiate it. X cube is going to be 3x squared minus 18kx plus 27. So this is 3 being common. We have taken 3 outside. It's x square minus 6kx plus 9. Okay. F dash x is greater than, it is increasing, so it is greater than 0. So 3 is positive, so we don't deal with 3 now. We have to deal with x square minus 6x plus 9 greater than 0. And you already know that when we have nothing in our hand, if an ax square plus bx plus c, which is the quadratic equation which is greater than 0, what do we get? When a is greater than 0 and when b square minus 4ac, which is the determinant, is less than 0. Now when you compare this x square minus 6kx plus 9 with the ax square plus bx plus c, a is 1, already it is greater than 0, 1 is greater than 0. So only thing which is left with us is b square minus 4ac should be less than 0. What is b? Minus 6k. What is a? 1. What is c? 9. So you have b square minus 4ac should be less than 0. So this is 36k square minus 36 less than 0. I am taking 36 common. We will divide both sides by 36. So you'll get k square minus 1 less than 0. 36 you can just divide. So k square minus 1 is less than 0. So when you have k square minus 1 square less than 0, it is k minus 1 into k plus 1 is less than 0. And when you have two factors multiplied and when we have less than 0, what do you do? I already told you in the beginning of this chapter. When k minus 1 will be 0, when k is equal to 1. When k plus 1 is 0, k is equal to minus 1. So you have minus 1 and 1 here, and you have to take the values which is, because it is less than 0. Greater than 0 will give you something else. Less than 0 will give you something else. That is, it has to be between a negative 1 and 1. You can write k between negative 1 and 1. What does that mean? See, the options are not there. The first option is the correct answer, but it should not be less than equal to. That is, the correct option should be k between negative 1 and 1. That is going to be your answer. So there is some point here, and let me give you a disclaimer also, which you see on the right bottom. There is some catch here, but first is the option. Now this is very straightforward question, this one. Just differentiate it. F dash x directly we will find out. It will be 9x to the power 8 plus, I'm just differentiating it, plus 21x to the power 6. The 64 will be 0. So f dash x, you don't have to worry about anything. Everyone has the power which is even. X to the power even will always be positive. So 9 into positive plus 21 into positive, this f dash x will always be positive. And when you have a positive value, whatever you give x, it will always be positive. So x can take any value from any number existing, and any number existing is nothing but the real number. It's R. Alright, the answer is real number. You give any number, it will always be real number. So I'm making the real number here, number line here, minus infinite to infinite, any value you can take, and this negative infinity to infinity is pertaining to the r, which is the real number. This is the reference for you. This is all about this chapter. Thank you so much. Take care of yourself.